Hello and welcome to the channel. So we've got this Matterhorn amplifier, and this is a bit of a rare beast. So this is a custom hand-built amplifier, and this was made in a town called Ilkeston in Derbyshire, in the UK. This amp's in because apparently it started sounding a bit ropey, and I had a bit of a play through it, and it did sound a bit ropey, a bit distorted. But I thought this would be an interesting one for the channel. So let's have a bit of a look at what we've got here then. So we've got just an input, bright switch, volume, treble, middle, bass, standby, and an on-off switch there, pilot light, usual deal. Let's turn it round and look at the back. Check out this power cable. You can run a village with that. That's some serious power cable, that is, my word. Must be about 16 amps, I think. There we go. It's a bit brighter, so ignore that. It's just my number that I put on them. So I can see a 5Y3, an EL84, and that's probably a 12AX7. So it's a champ like amplifier. Now this thing's quite heavy as well. We've got a line out. We've got 4, 8 and 16 ohms on the speakers there, so that's really good. Versatile, really well made and really well covered. It's a nice bit of kit. Cabinet is made of looks like birch ply. Really top drawer bit of kit. But let's see what it's like inside. So we're going to get it out of the cabinet and get it in the cradle, because I need to do some voltage measurements and so on, check a few things. Right, looking inside, and that's quite a tidy thing. Not a lot in it, but it's only a 5-watt amp. Nice and basic. So let's have a look what we've got. Stop it, pink. Immediately I'm filming, of course. Here's pink again. So let's just get a pen. So yeah, so we've got 68k grid stopper there. That would have been probably better on the pin of the tube there, but it's okay. 1 meg grid leak. Got a capacitor here, 1.5k, that's the cathode resistor, and we've got, that is 22 microfarad. Let's put another light on. Oh dear, that's let's not put another light on. 22 microfarad. Yeah, so let's just zoom in a little bit, shall we, and we can have a look, a bit more of a look. Right, so cathode resistor, cathode bypass cap, cathode resistor, cathode bypass cap on the second stage. So this must be quite hot. So we've got ground coming to there, and then we've got a 2.7k resistor here, and that's going on. To this, what is that? So that's negative feedback then, because that's going to the speaker. So we've got negative feedback there, because that wire goes under there into that bench there, goes onto the speakers. So I'm guessing that's negative feedback. Got another resistor there, which is really tiny, and that is 47 ohms. So that'll be part of this negative feedback thing. Then we've got cathode resistor, bypass cap. So we'll look at that one, is 22 microfarad. 100k plate resistor here, that's to pin 1 there, and that's the treble cap. That'll be, that's the base cap, and that's the mid cap. That's the slope resistor, which is 100k, and this amp is switched off, by the way, and the caps are drained, so I don't need to be. 100k slope resistor there for the tone stack. What we got there, 0.1 0.47. That'll probably be something like 250 pico, can't see for sure. Plate resistor here for pin 6 there, that's good. And then we've got a capacitor here which is 22 nanofarad going into here, and we've got this 220k which I'm guessing will be grid leak. That goes into pin 2 of the grid. So we have got a grid stopper on there, and that is actually on the tube socket, and that is 6.8k. 22 microfarad bypass cap on the cathode of the output tube, and we've got a 270 ohm resistor there. But yeah, basic, that's the basic circuit anyway. And then this is obviously, we've got the power supply up here. So an interesting design, very interesting. Bright cap on here, we just come down, you can see, and here bright cap on there for this on the switch there. If you can hear that noise, it's Pink sat under the camera purring, being very annoying again, because that's what Pink specialises in. Well built, very well built. Yeah, screen cable used for the tone stacks and for the input, so that's excellent. Bit of screen cable going into the grid there on the output tube, so that's excellent as well. It's a really, really nice looking amp, really nice. Really, really solid and well built. These boards barely flex at all. Excellent. Not sure about the jack sockets though, but I think some switch crafts in there would have been better, but as long as they work. Soldering is excellent. What I can see, yeah, soldering is excellent. Yeah, really good. But what is that? It smells like the dreaded WD-40. Not sure what that is. I think we'll clean that out. You don't want that in there. Looks like it's probably been sprayed into this input socket and sprayed back onto the chassis there. There we go, clean that up. No big deal. There's a bit more there as well. Right, I suppose we best plug it in and just have a look, get some voltage readings and see if we can find anything that's amiss. I suppose we could test these capacitors if we're looking for something that's making it sound a bit groggy. It doesn't sound wonderful, and the guy, that's the complaint with this guy, says it just suddenly started to sound awful and distorted, and it does a bit. 18.9, have a look there. 18.49, no ESR, so that one's okay. Just leave that on the ground. What happened there? $21.3, no ESR, naught ESR should I say, see that? So that looks okay to me. Let's try this one. That's the cath. Oh, man, that could be because it's in circuit. But we'll check that just in case. Let's have a look at these F and T's. So good quality caps in there, and that's an Ichicon on the end. So yeah, no expense spared on the capacitors, eh? They're excellent. Yeah, no, that's perfect. Yeah, same again on there, spot on. Let's try this one. 43, is that a... Well, they look like they're parallel on there. So this amp's got a 5Y3 in it, and that's probably borderline too much capacitance for that. No diodes on the tube socket there. Belt and tube sockets used by the looks of it. Excellent. Yeah, a nice bit of kit, but we need to find out what's wrong with it. And before we do anything else, we need to get rid of Pink, because of course she's not allowed on the bench when there's high voltage. So we'll plug the speaker in. She's not very happy, is Pink. Because she's not getting any treats. By goodness, look at this cable. That's a serious piece of wire, that is, my days. Right, let's get a meter on it. We'll start taking some readings, I suppose. We'll just get a handle on how much volts we've got coming into it from the 5Y3. So there we go, looking at the meter there, that's what we've got coming in, but the standby switch is on. Let's flick the standby switch, switch it out of standby. Now we've got about 300 volts there. Pretty quiet for a single-ended amp. You always have a little bit of background hum. That's flat out at that as well, so nice quiet amp. Very nice. Nice chassis, really well made. Really well made amp. So 298 coming off of there, because it's going up on the wall voltage. Incidentally, if we look at the wall voltage, look, 242 volts now. So if we come to this side of this resistor, we've got 287. And then if we go to this resistor here, 208, yeah, that's the same. 265, just turn the volume down a bit. 265. Right, so we should have that 265 should be here, and there it is, near enough. Yeah, and that plate resistor there we should have, yeah, 171. Got on the tone stack, 166 there, 168 at the side of there. So have we got about 265 there? Yes, we have. What we got there, we've got, now we're down onto the plate resistors of the preamp tube, 168 on that side. So 168 on that plate resistor. Oh, 172. Sorry, I must have misread that then. Yeah, that's okay. So that all looks right. What we got on this cathode, about 1.5 volts, 1.4 volts, yeah. 1.5 or, yeah, 1.4. So that's right. So all the voltages check out there. So cathode resistor, we'll just do a quick window with that, without measuring that cathode resistor. Let's take those off now. It's humming, it's just the meter, because I put the meter in where you can see it. So let's have a reading across the cathode resistor then. So we've got 10.2 going across there, 10.2, and let's measure plate to cathode. So there, and then pin 7 there, 252. So 252. So where's our calculator? Right, so let's just do the maths on that. So we have 10.6 divided by 270 gives us 39.2 0.2 milliamps, take away 5% for the screens, times 252, 9.39, let's go to that, 9.39 watts. That's biostat. So yeah, so the only thing we need to check is that bypass cap there, because we got in circuit leaky on it, but I think that's probably because it's in circuit. Yeah, really well made amp, quite nice, really nicely wound filament wires, look there, really well made. It's got an HT fuse as well. Yep, top drawer. So let's check a few resistors then, go through and see what see if we've got any problems there. 1.5, that's good. That probably needs testing out of circuit because negative feedback. Well, that's measuring exact. That's measuring at 46 ohms, but I say it's probably because it's in circuits, in the negative feedback circuit. That's bang on, 1.5. Let's try this plate resistor, 100k. That's bang on. Let's try the slope resistor, 105k. Let's try this plate resistor, 100k. And this 220k. 233, that's gone up a little bit, but yeah, let's try that drop-in resistor. That should be 10k, and is. And then there's a resistor here, .2k, and it is. So all the resistors check out as well, all of them. The only thing we've not checked is that, so we'll just lift that out of circuit and test it. Right, I've got that out of circuit. Let's give it a test. No, he's fine, no problems with him, just because it wouldn't test his circuit, that's all. So that's absolutely fine as well. So component wise, can't really find anything wrong with it. Everything's, all the resistors seem to check out. We could check the screen voltage and make sure that's right. Let's just check that screen resistor there and see what that's 465, that is. Not with a feed in it. So is that from there to there? No. That side. Okay, I'm on the wrong side. Yeah, so that's right. So that is the actual screen resistor. Then the dropper is the 2.2k between this node, because these, remember, these are one node, and these two caps here. And then there's a 10k, you can't really see it the other side of there, there's a 10k dropper. So if we go that side of the dropper, same side as this resistor there, and we go to there, we get, yeah, we get continuity. So yeah, so that'll be a 470 ohm screen resistor. And the thing with these is you can't put these on the tube base anyway, because the pins that are not being used are internal connection. What I've done in the past is put just a little tag strip on there to get it close to. It doesn't, to be perfect, it has to be close to the tube, but it's not too far away, so it's okay on there. But that's one thing I've done in the past. I've just so it's just really close to the pin. The idea is they're supposed to be as close, but you can't get it on the tube, so there's no way. So that's fine where it is. Yeah, so that all looks right. Let's just measure this cathode resistor. See if there's anything untoward with that. I don't think so. And that's 277, is that measuring? It's a little bit over. 278. 278. So it's 8 ohms over. That's nothing to raise the rooftops about, is it? So all the components check out. I can't find anything at all that seems untoward. So we'll just check the screen voltage, which probably won't be a deal different to the plate voltage. Let's have a look. Oops, put it on DC. 278 on the screen. Oh, what's going on there? 263 on the plate and 279 on the screen. So we've got more voltage on the screen than we've got on the plate. So I'm just going to switch the top light off there, put the other one on. So if we look there, can you see where that wire's burnt there? Put the meter on it. Be careful not to push it to ground. There we go. We've got that's burnt right through with the soldering iron, and we need to put some insulation on that, because if that gets down to the chassis, that'll be a dead short. If we go in, look, if I touch the wire there, got to be careful doing this. See the voltage there, 280 volts. So we need to address that, because that's not safe. And if that gets onto the chassis, guy's probably just caught it with a soldering iron, where, you know, when he's been working and not noticed. It's easy done when you're working. And the guy that owns this says that the chap that made this is now retired, so, you know, he probably an elderly gentleman, and it's probably his eyes. My eyes aren't fantastic either, so if you've not got the right glasses on, it's easy to do. So it's just nothing. It's dangerous, but we can sort that out. A bit of shrink tubing around that, it'll be fine. It happens, unless of course someone else has been in here servicing. That's also a possibility as well, but that happens. It's a genuine thing. To be fair, if you look in the amp, it's absolutely, everything else is absolutely immaculate. There's no, because the thing is, you can always tell when a professional's made an amp, because if you start to look at these, like these cables here, where they go in, they'll be burnt. If it's someone that's not professional, you know, you see all black on here a lot of the time, where they've held the iron on too long and melted the insulation. But you don't see any of that on here. It's very professionally made, all of this, everything in it, and that's just a mistake. Anybody can make that. It's just one of those things. Like I say, it's probably not even noticed. It's just, it happens, but we can sort that out. It's no big deal. It would be if it caught on the chassis, mind, but I like this chassis a lot. Really nice, really thick, proper steel. And it's I don't know whether he's made that himself. It's all professionally welded, and really nice cabin chassis. Excellent. See the welds on here, top drawer, and all along here. By the look of it, it's been welded up there. It's yeah, very nice, very nice indeed. My only criticism of this would be those sockets. That's all. They just look a bit cheapy, but other than that, with the switchcrafts in. But that's the only thing I can, if I was looking at this, I'd just say, well, they could be better, but they work. So, but that's the only thing. Everything else in this amp is absolutely top drawer. It's really, really nicely made. It's excellent. So what's wrong with it? Because we've checked every component in it. None of these components have got problems. Those caps aren't showing any leakage on we've got no hum either. No AC hum on the caps. When you turn it flat out, it's obviously, but it will be if it's cranked. It's a single-ended amp, you're going to have a bit of noise. But that is absolutely, that's everything flat out. Treble, bass, middle, and the volume. And part of that could be because it's not in the cabinet. It's got no, yeah, got screening on the top of the cabinet, so it's probably just because it's not screened. There we go. Got some shrink tubing on there, and that's all good. So yeah, good stuff. Well, that's it really. The only thing to do now is just put it on the scope and see what we can see. It seems to have a bit of breakup at low level. I wouldn't expect it to have that. Although having that second bypass cap on that second stage there does quite often make them a bit more gnarly. That seems pretty clean now. It's just if you really lean on it. Crank it up anymore because we're on the night shift. It's about 10:30 and my neighbour works early, so if he's not in bed already he won't be far from it. Yeah, well. Nice and bright with the bright switch on. And quite warm without it. something, isn't there's just something there that's just, I don't know, something that's just not right. Let's just look it on standby. Let's just try some of the other tappings for the speakers. I don't think that line, I don't know if that line socket on the end is connected up, you know. Let's try. Try the other one. Try the mid. Something just not quite right there. Just looking on the scope there, and everything looks pretty all right there. Obviously when we crank it, but yeah. Right, I've just lifted that 2.7k resistor there, because that was the only, just remembered we didn't actually get a reading off that component with it being in the negative feedback, and it would make sense to look in the negative feedback circuit because the symptoms we have a little bit high, but I wouldn't have thought that to be a massive issue. Well, it's not actually 2.7. Let's have a look again. No, it's not really. That's about right. 2.79. It's a tiny bit over, but nothing. So that's okay as well. One of the things we could try in this amp though is a solid state rectifier, which would be an easy test because I have one here. Now because the plate voltage is pretty low on there, so what we'll do, we'll get Pink off the bench. You've got to go Pink, I'm afraid, so tatty bye. There we go, we'll go. Otherwise we may end up with fried cat. So we'll switch on. The other problem as well with this is we've got a standby switch on here. So having 40 microfarads on there, and then clattering it with this standby switch, the ripple on that rectifier tube will shorten its life considerably. It's very stiff on the bottom end. Having said that, I've put 47 microfarad on a, you know, on a single-ended amp before, but it's been solid state rectifier as well. So what we're going to do is just take some more readings, just to remind ourselves of what. And I have edited some of the video through already, so let's just work off. We should be working off plate to cathode really. Let's just so plate to cathode, we've got 268 volts. Just check the screen, 265. Now I seem to remember when I checked that screen last night, and I remember saying it on the video, that the screen voltage was higher than the plate, but it's not now. Let's just measure that from plate to ground now. 281. Measure the screen, 275. So I don't know, did I misread that, or is there a problem there? I don't know. Is there a problem in this power supply? But that seems okay now. So if we go upstairs, we could just work off plate to ground. It doesn't matter, because we're just looking for a voltage. So we've got 233 volts going in off the wall. We've got 287 plate volts. So if we use the other meter, if I use the other meter and measure across the cathode resistor, we should have about 10 volts, and we have just shy. But yeah, so we've about 276 plate to cathode. Remember, this amp's cathode biased. Right, so we'll say 286. So we'll switch off, and we'll get that rectifier tube out. And I've got the glove here. Right, I've got the solid state rectifier in. So let's just we'll just switch on. And obviously with this in, the standby switch is not such a big deal. And you can see we've got 354 there. So let's go down, because obviously the tube's got to then pull that down. You can see now the voltage is 328. So that's put, what did we have before? 286. So that's put about 42 volts on there then. And that's dropping now as the tube gets a bit hotter. In fact, it's just dropped a shade on the wall as well. Let's have a look what we've got across the bias resistor now. 11.36 across the bias resistor. So 11.36 divided by 278, remember that resistor is, when we tested it thoroughly. That's given us 40.8 milliamps. So we take 5% for the screens, that's 38.8. And so we've got 327 less, in fact that's still coming down, 326. So call it 327 less 11, so that's what, 316. 12.2. So the bias is now spot on at 100% for the tube at 300, and at 300, and so 11 volts off that. So yeah, about 316 volts. So it's perfectly acceptable to have that in there. That's worked pretty well. So let's plug into it now with the guitar. Right, I've got this on a 1B12 Marshall 1912 cab, and now it sounds really clean. The arthritis is giving me some today again. So that sounded really clean now, really clean. So we've got the solid state rectifier in now. So the tube's now biased at 12 watts. That's as clean as a pin. Yeah, that's pretty clean. Got the bright switch there. So why has it just suddenly cleaned itself up all of a sudden? Let's try the rectifier tube back in it then and see what we get with that. Right, we've got the rectifier tube back in now. So that JJ will be biased at 9 watts again now, and we'll have less plate volts. So let's just bit now. I think that without a solid, I mean, it seems to have corrected itself, because it didn't sound that good on the bench, did it? Yeah, definitely cleaner with that solid state rectifier. I mean, the amp's corrected itself, but that, yeah. That does sound nice. Whoops. Rusty, but yeah, that's sounding very clean now. So for some reason, since we've moved it off the bench and put it in here on this one, well, we got it on this 1B12 before as well, completely cleaned up. But obviously the solid state recce's really cleaned it up even more, simply because we've got more plate bolts and we've got more headroom because the tube's now biased at 12 watts. Yeah, that's sounding pretty nice, that is now. So I don't know, so what's going on there? Have we got... Well, I think we can just wrap that up now, and I'll put it back together and just see how it is. And so let me know in the comments what you think about this circuit in this amp. Sounds fantastic now, just sounds awesome. And let me know whether you'd use the solid state rectifier or whether you'd use the 5Y3. I'd certainly go for the solid state recce, and it makes total sense on this amp. One is we've got a standby switch with 40 microfarads of smoothing there, and that is too much for that 5Y3. With a solid state rectifier, there's 43 microfarad there, we measured, that's absolutely fine, standby switch fine. So it just makes total sense to use that. There's more plate volts, more headroom, the tube's now biased at 100%, and the amp sounds phenomenal. A really nice amplifier as well, really well built. Let me know what you think in the comments. But that'll do it for this one, so thanks for watching, you all take care, and I'll see you all in the next one. Bye bye for now. So I've just checked the transformer with a solid state rectifier in there, and this transformer's barely warm at all, so that's well up to the job.